Hello GCC, welcome to Chapter 8. We're going to talk about acids and bases now in Chem 130 here at Glendale Community College. My name is Dr. Kim. So first I want to tell you a little bit about chemical reactions. When we write chemical reactions, the chemical formulas that are on the left side of the arrow are called reactants. And then they turn into products which we write on the right side of the arrow. We include states for these chemicals by putting them in parentheses. An S is for solid, L is for liquid, G is for gas. And then we have a new indication for chemical reactions, if you will, called aqueous. In parentheses, it's an AQ that stands for aqueous, but what that means is it's dissolved in water, like salt dissolves in water. So if we had salt in water in the reaction, we would write NaCl with parentheses and an AQ next to it. So when we write chemical reactions, we put the reactants on the left side, products on the right side with an arrow in the middle, and then we include these states. All right, let's get into it. Acids. What you really need to know from this slide is that acids produce H plus ions in water, hydrogen ions in water. So what happens is you put an acid into water and an H plus pops off. So we make H plus ions, and that's what makes something acidic, is that H plus floating around in the water. It tastes very sour like lemons or oranges. It can be very corrosive if it's a strong acid, if it's concentrated, and it turns blue litmus paper red. But remember, acids make H plus ions. Bases. Bases produce OH minus ions in water. That's one of our polyatomic ions from our periodic table in the corner here. OH minus ions are named hydroxide ions. So bases, one type of base can contain hydroxide ions, and when you put them in water, the OH comes off. So they make OH minus ions that float around in the water. When you have OH minus ions floating around in the water, it tastes chalky and nasty. We don't like the way bases taste. They can feel soapy or slippery like soap or bleach, and they turn red litmus paper or blue. But what you need to remember is that OH minus ions, hydroxide ions, are what bases produce in water. So typically we talk about Arrhenius acids and bases. That's just the scientists that came up with these definitions. So an Arrhenius acid produces H plus in water or aqueous solutions. And look at our little chemical reaction here. We have HCl as the reactant, then the arrow, and it separates into H plus aqueous plus Cl minus aqueous. See that H plus pops off of the HCl and leaves Cl minus, and then the H plus when we put that in water. Now bases produce hydroxide in aqueous solutions or water solutions. NaOH aqueous in water will separate into Na plus ions and the OH minus hydroxide ions. So that's just an example of a chemical reaction showing that acid making the H plus and showing a base making the OH minus ions in water. Great. So one thing we can do now with acids and bases is put them together. And generally, acids and bases neutralize each other. We call it a neutralization reaction. In one type of acid-base reaction, an acid plus a base react and make a salt and H2O water. There is more than one type of acid-base reaction. We're just going to focus on this type, however, where we make salt and water. So for an example, HCl, that's an acid because we have that H there that can pop off. Plus NaOH, that's a base because we have that hydroxide ion, OH, which can pop off. When we put those together, the H pops off of the acid, the OH pops off of the base, and we put that H and the OH together. What is HOH? I hope you said water. Yeah, HOH is H2O, water, right? So we made water. And then what's left over is the Cl minus and the Na plus. And that is our salt NaCl dissolved in the water. So it gets that AQ designation, the AQ. A salt can be any ionic compound, not just NaCl. So really any ionic compound, you can call that a salt. All right, so neutralization reactions that we'll do in this class, Chem 130, produce an ionic compound or salt and water. Now, there's another type of acid-base reaction called Bronsted-Lowry acids and bases. And this is really more important if you're going on in chemistry. We're just going to have this one slide on it. Don't worry about this too much. But we're going to define an acid now as a proton or H plus donor, because it will lose the H plus. Again, this is according to the scientists Bronsted and Lowry. And a base is a proton H plus acceptor. It's going to gain the H plus. So that's different from the hydroxide definition we had with the Arrhenius acids and bases. So it's a little different. Let's look at a reaction of Bronsted-Lowry acids and bases. HCl plus NH3 will make NH4 plus, so that changed, and Cl minus. And look at the little picture right over here. That way, look at the little picture. We have a picture of HCl where H is yellow and the Cl is red. Then we have NH3, N is blue with the 3 yellow H's. And then we're going to make NH4, so we got the blue N and the 4 yellow H's. And then Cl minus is by itself, the red circle. So what really happened here before and after this reaction? Look at the picture. What's different? What changed? What happened? Well, if you said the yellow dot went from the red circle to the blue circle, you're right. That's what happened, right? We don't have the yellow dot or H on the red circle anymore over here. It's gone. So the hydrogen transferred from the Cl to the nitrogen and made NH4 plus and Cl minus. So the acid is what loses the H plus and the base gains the H plus. So which is the acid and which is the base? You are correct if you said HCl is the acid. It is because it lost that H, and NH3 is the base because it gained the H and became NH4 plus. Yeah. So the HCl is the acid. It lost an H plus. The NH3 is the base because it gained an H plus. So again, this H plus transfer from the acid to the base is just another type of Bronsted-Lowry, is just another type of acid-base reaction called Bronsted-Lowry reactions. And again, we're not going to cover these much in this class, just showing you an example of a different type of acid-base reaction. We're going to focus much more on the Arrhenius definitions. So again, don't really worry about this, but you'll see it if you continue on in chemistry. Okay, back to our Arrhenius definitions. Here's an Arrhenius acid-base reaction. Remember, Arrhenius acids do what and bases do what? So let's look at this reaction up here. We have 2 HNO3s in the water, AQ means in the water, plus CaOH2 in the water, and it's making 2 H2Os, which is a liquid because it's water, so it's a liquid, plus CaNO3 twice aqueous. All right, which one of those is the acid and which is the base? All right, I hope you said the HNO3 is the acid Because it has an H. I'll give you a hint. We put the H's in front of acids so you know which H comes off. So HNO3 is an acid. Okay, which is the base? Remember, Arrhenius bases contain what? Hydroxide. So the base is the CaOH2. Yes, HNO3 is the Arrhenius acid and CaOH2 is the Arrhenius base. Now look at the salt we made, the calcium nitrate. Why is the Ca bonded to two nitrates? Why is it CaNO3 in parentheses with a 2? Why do we need two of those? Any idea? Well, it has to do with charges. Remember when we had our nomenclature chapter and we talked about charges are so important. Calcium is a +2 charge. Nitrate is a -1 charge. So we need two of them to go with the calcium. Calcium is +2, nitrate is -1. We need two nitrates to match up with that calcium and make the compound, the salt, the ionic compound, add up to 0. Remember, compounds have to be neutral and add up to 0. So +2 -1 -1 equals 0. All right, very good. All right, strong acids and bases. Strong acids ionize completely, 100% in water. That means when you put the acid in water, all the H's that are acidic will pop off. Know these three acids. HCl has an H in front. It's an acid, hydrochloric acid. HNO3, nitric acid. It has a nitrogen, nitric acid. And then H2SO4, sulfuric acid. It has a sulfur in it, sulfuric acid. Those are your strong acids. So you need to learn those three: hydrochloric acid, nitric acid, and sulfuric acid. By ionizing completely, I mean they make H+ in water. Let's look at the reaction. HCl as a gas, if we bubble it in water, it will produce in water the H+ separating from the Cl-. So again, H+ pops off when you're an acid. Strong bases are similar. They dissociate completely. Dissociate means break apart into ions as well. And they do this 100% because they're strong. Strong means 100% breaking apart. They break apart to form ions. Here's your two strong bases, KOH and NaOH. What's the name for those? You should know. Potassium hydroxide and sodium hydroxide. Very good. Let's look at a reaction over here with sodium hydroxide. NaOH is a solid, but if you sprinkle it into water, that OH- pops off. And we make Na+ and OH-. So they get those AQs in parentheses because they are dissolved in water. So again, we can see these acids dissociate and ionize completely 100%. The arrow goes one way. Okay, it's a one-way arrow. All of the acid in the base break apart into ions. All of it, 100%. Strong, strong, strong. Here's a picture of what those acids and bases look like when they are in water, if you will. And we're going to be doing a lot of these beaker drawings, so it's important. Let's look first of all at the HCl. Notice we have H+ Cl-, H+ Cl-, H+ Cl-. Because it all dissolved in the water and broke apart. It ionized. Now let's look at the NaOH. We have Na+ OH-, Na+ OH-, Na+ OH-, all apart into ions. Again, all of it is ions because it's strong and it dissociated 100%. You're going to be drawing these pictures for this chapter, so look at those really well. All right, so strong acids and bases. The acids are hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, H2SO4. The bases that are strong are sodium hydroxide, NaOH, potassium hydroxide, KOH. What does strong mean again? All right, it means it breaks apart into ions 100%. It all dissolves and ionizes in the water. What ions are produced for water, in water for each of these again? What do acids produce? H plus, I hope you said H plus. What do bases produce? I hope you said OH minus or hydroxide. Good job. All right, let's talk real quick about weak acids and bases. Weak acids only ionize a little bitty bit, 1 to 5% in water. So only a few H pluses pop off. Most of them stay bonded to the rest of the molecule. Okay, only 1 to 5% ionizes in water. You have 4 weak acids to learn. HF, hydrofluoric acid, H2CO3, carbonic acid. There's a carbon in there, so carbonic acid. C2H3O2. That looks like a monster molecule, but it's not that bad. If you look at your polyatomic ions, for a lot of these, you can put H's with them and they make acids. That's just acetate with an H. And acetate with an H is called acetic acid. And then H3PO4 has a phosphorus in it, so it's called phosphoric acid. So those are your 4 weak acids. Here's an example equation showing the acetic acid. So we have C2H3O2 in water, but we have a double arrow because not all of it goes to the products. Just a little bit makes H plus C2H3O2 minus. Most of it stays bonded together. 95% stays on the reactant side, HC2H3O2. Only 1 to 5% makes that product H plus C2H3O2 minus ions. Again, most do not break apart. Most of the H's do not pop off. Only 1 to 5% of the acid ionizes. It's weak. Weak bases are similar. They only dissociate 1 to 5%, so just a few ions form. The only weak base we're going to discuss is magnesium hydroxide, MgOH2. Let's look at the equation. We have MgOH2, which is a solid, but if you sprinkle it in water, it'll break apart a little bit, 1 to 5%, to Mg plus 2 ions and 2 of the hydroxide ions. Let's look at the pictures. So the HF beaker drawing, again, shows mostly together molecules of HF. HF, 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 HF. Only one of them has ionized into H plus and F minus. Again, that represents the 1 to 5% that ionizes. Most of them molecules stay together and do not break apart. Now, the magnesium hydroxide base is a little bit different than that because it's an ionic compound with a metal. So that means it's a solid. So when you sprinkle it into the water, most of it sinks to the bottom. So that squiggly line here just represents a big clump of solid at the bottom. So we just put MgOH2 in there and it represents that clump that is solid at the bottom. 95% is down here. Again, only 1 to 5% makes ions. So we're going to draw an Mg2 plus ion and 2 OH minus ions. It has to be adding up to 0, remember? So because Mg is a plus 2, you need 2 OH minuses to go with it. Because we need plus 2 minus 1 equals 0. Okay, so that's how a picture of magnesium hydroxide base looks. All right, so the weak acids. We have 4 weak acids: hydrofluoric acid, carbonic acid, phosphoric acid, and acetic acid. We have 1 weak base, magnesium hydroxide. And I think this is a great place to stop. So we will pick you up in the next video for Chapter 8. Bye, GCC.